Howdy students, I want to make sure you understand concentration, and specifically in this video I'll be talking about molarity and how to calculate it. So solutions expressing the amount of solute dissolved in the solvent is something called concentration, and the most common way to express it is in the big M, which is molarity, and that happens to show the number of moles of solute in liters of solution. So for chemists, they're not totally satisfied with saying something has low concentration or something has high concentration. They want to know exactly how much is dissolved. And the reason why we use these units of molarity is because typically reactions are not performed well when you mix solids or gases, but when you dissolve these substances into a solution, making it in an aqueous form, then they tend to react better. So if you take two solutions, for instance, and you express their concentration, it would be in the form of molarity or big M. Notice these two here. And with that, you basically say how much solute is dissolved. So you would say these are 0.1 molar solutions. Now this helps when you have a reaction and you want to express how much of the acid and how much of the base, hydrochloric acid, sodium hydroxide, are reacting. This is a good thing, and this is why we use it. So let's go ahead and look at the formula and how to do a couple of problems. So the formula, molarity, big M equals moles of solute over liters of solution, is the one that we're going to begin with. Now using that, let's go ahead and try to solve a simple problem like this. Reading through, you notice it says molarity. Molarity is going to give you a key that you need the formula we've been talking about. And when you read through, it says there's a volume of 0.5 liters and there are 2 moles of sodium hydroxide dissolved in it. So just taking those givens and placing them in the molarity formula, you'll see that you can plug in or substitute the 2 moles on the top and the 0.5 liters on the bottom. And that gives you the answer that you're looking for, which is the molarity, 4M, or 4 molarity of NaOH. Now, what about a more complicated variation? One that doesn't have an easy plug in and solve. This one says how many grams of sodium hydroxide will be needed to make 650 milliliters of a 1.6 big M molarity solution. When you do this one, first thing you need to do is think about your molarity formula, and then think about what the givens are in this equation, in this problem that you're doing. 1.6 M can plug in for M. But you don't know the moles and you don't know the liters, but you can get to the liters. Starting with the 650 milliliters, go ahead and convert that, dividing by 1,000, plug that in for the liters. Now you simply need to find moles, and the way I'm going to do that is by substituting into my molarity equation with what I know, but I don't have moles, therefore I'm going to cross multiply and solve. My answer comes out to be 1.04 moles. But again, if you look back at the question, they asked me for grams. So it just takes one simple conversion to get from moles to grams, and you'll do that by multiplying by the molar mass of the solute NaOH. And then your answer is 41.6 grams of NaOH. That's how you do it. There's 2 examples. Good luck, my friends.